Lesson. Motion word problems. We see in order to move. We move in order to see. Wilson Gibson. How to solve motion or distance word problems. Step 1. Draw a diagram to represent the relationship between distances involved in the problem. Step 2. Set up a chart based on the formula DIRT. Step 3. Use the chart and facts of the problem to write one or more equations. Step 4. Solve the equation. Types of motion problems. 1. Catch-up. Two entities move in the same direction. One entity starts after the other and travels at a faster rate of speed to catch up with the first entity. They travel the same distance, d1 equals d2. Both phrases catch up and overtake mean the two entities travel the same distance. 2. Motion in the same direction. One entity starts at a point and moves in two or more segments of a trip at different rates. The average rate of the entire trip does not equal the average of the rates for each segment of the trip. The average rate of the entire trip equals the ratio of total distance traveled to total time traveled. Motion in opposite directions, two entities. A. Start at the same point and move away from each other. The sum of the distances traveled by the two entities is equal to the total distance traveled, how far apart the two entities are. B. Start at different points and move towards each other. The sum of the distances traveled by the two entities is equal to the total distance traveled, how far apart are the two entities. The entities pass each other. 3. Motion round trip. An entity travels from one point and returns to the same point at different rates. Important! The average rate for the entire trip is equal to r equals d1 plus d2 over t1 plus t2. The average rate for the entire trip is equal to the ratio of total distance traveled to the total time traveled. The average rate for the entire trip is not equal to the average of the two rates. 4. Motion in perpendicular directions. Two entities start at different points, move in perpendicular directions, and travel at different rates. The Pythagorean theorem leads to an equation that allows us to find the introduced variable. The sum of the squares of the two distances traveled is equal to the square of the distance between the two entities. Questions that should be answered before an equation for the problem is written. Do the entities travel the same or different distance, rate, or time? What variable should be introduced? And what fact of the problem leads to an equation that allows to find the variable? Example 1. Outdoor skating rinks offer the chance to glide across the ice in some of the most breathtaking locations on the planet, from a spectacular remote winter wonderland to the heart of a major city decked out in its holiday finest. Emma lives in NYC and went out for a 36-mile skate, but after she had skated for 30 miles, she decided to walk the remaining 6 miles. She walks 12 miles per hour slower than she skates. How fast was Emma walking if she spent the same amount of time skating and walking? Construct the DIRT tables. Emma skated for 30 miles but walked for the remaining 6. She walks 12 miles per hour slower than she skates. Let x equal the skating speed in miles per hour such that x is greater than 0. Thus, the walking speed is equal to x minus 12 miles per hour, x greater than 12 because her walking speed cannot be less than 0. The distance and rate are known, thus we can find the time using the DIRT formula. DIRT results in d distance equals to rate times time, which is equivalent to time equals distance over rate. She spent the same amount of time skating and walking. This fact leads to the equation 30 over x is equal to 6 over x minus 12. This is on the domain open interval 12 infinity. The GCF of the numerators is 6. Divide both sides of the equation by 6, which is equivalent to 5 over x equals 1 over x minus 12. Two equal fractions make a proportion. Apply the cross product property of a proportion. Equivalent to 5 times the quantity x minus 12 equals x. Eliminating parentheses and applying the distributive property of multiplication over addition. 5x minus 60 equals x. This is a linear equation with one variable. Separate the variable. Add 60 and negative x on both sides of the equation. 4x equals 60. Divide both sides of the equation by 4. Equivalent to x equals 15, which belongs to the domain open interval 12 infinity. How fast was Emma walking? X was the skating speed in miles per hour. The walking speed was x minus 12. And since we found x to be 15, her walking speed is equal to 3. Answer: Emma is walking at a speed of 3 miles per hour. This is an example of a motion problem with one entity moving in the same direction at different rates. The goal of the problem was to find the rate for a segment of the trip, knowing that the times for both segments of the trip were the same. Notice, no sketch was needed to solve the problem because there was no relation between the two segments of the trip. Example 2. The buzzing vibrancy of the city that never sleeps just energizes skating there. Rolling down the avenues surrounded by the flurry lights, diverse cultures, and massive skyline is enough to make you feel like an immediate superconductor. Nicole decided to go to New York City and drove 70 miles per hour for the first 2/3 of a trip and an average 50 miles an hour for the entire trip to skate on a special place. What is her average rate of speed for the last third of her trip? Construct the dirt tables for each part of the trip. She drove 70 miles per hour for the first 2/3 of the trip. Let 3x is equal to the number of miles from Nicole's house to NYC, such that x is greater than 0. The entire trip, d equals 3x. Thus, the first 2/3 of the trip is equal to 2/3 times 3x, which is 2x. The reason we chose the total distance to be 3x is that 2/3 of 3x leads to an answer with an integer coefficient. The distance for the second part of the trip is equal to the difference between the distance for the entire trip and the distance for the first part of the trip, which is 3x minus 2x equals x. She averaged 50 miles per hour for the entire trip. We know the distance and the rates, thus we can use the DIRT formula to find the time traveled on the first part of the trip and the entire trip. DIRT, distance equals rate times time. Time is equal to distance divided by rate. Filling those in, we get time 2x over 70. Reducing the fraction by the GCF of 2 of the numerator and denominator, we get a time of x over 35. Similarly, for the entire trip, we get a time of 3x over 50. The time traveled on the second part of the trip is equal to the difference between the time for the entire trip and the time on the first part of the trip, which equals 3x over 50 minus x over 35. The prime factorization of 35 is 5 times 7, and the prime factorization of 50 is 2 times 5 squared. The LCMD is 2 times 5 squared times 7, which is equal to 350. Bringing to the same denominator, 350, amplifying both fractions by 7 and 10 respectively, we obtain 21x minus 10x at the numerator, or 11x over 350, which is our time for the second part of the trip. We know the distance and the time. We can use the DIRT formula to find the rate for the second part of the trip. DIRT, d equals RT, r equals d over t. R here is equal to x over 11x over 350, which reduces to 350 over 11 miles per hour. Answer: the average rate of speed for the last third of her trip is 350 over 11 miles per hour, which is equal to 31 and 9/11 miles per hour. Notice that we introduced a variable. However, we didn't need to find the variable in order to find the average rate of speed for the last third of the trip. This is an example of a motion problem in one direction with different rates. This problem required to find the average rate. Notice that the average rate of the entire trip, which is 50 miles per hour, is not equal to the average of 70 and 50 miles per hour. The average rate for the entire trip does not equal 60 miles an hour. Example 3. Australia hosts some of the best metropolitan areas on the planet. With a shout out to Sydney, Melbourne has become the main travel destination skate-wise there over the past 5 to 10 years. Elia and Jasmine enjoy skating in Australia. Both of them skated 20 miles. Elia was 2 miles per hour faster than Jasmine. The sum of their skating time was equal to 4.5 hours. How fast was Jasmine skating? Construct the dirt tables. They each skated 20 miles. Elia was 2 miles per hour faster than Jasmine. Let's let Jasmine's speed equal x miles per hour, such that x is greater than 0. Elia was 2 miles per hour faster than Jasmine. Thus, Elia's speed is equal to x plus 2 miles per hour. We know the distance and the rate. We can use the dirt formula to find the time for both Elia and Jasmine. So dirt, as d equals rt, we can change it up and write it as t equals d over r. So for Elia, his time is 20 over x plus 2, and for Jasmine, her time is 20 over x. The sum of their time skating was equal to 4.5 hours. So this fact leads to the equation 20 over x plus 2 plus 20 over x equals 4.5. On the domain, open interval 0 infinity. To eliminate the decimals, we multiply both sides of the equation by 2. Applying the distributive property of multiplication over addition, we obtain 40 over x plus 2 plus 40 over x equals 9. This is a rational equation, bring to the same denominator using the LCM d x times the quantity x plus 2. Doing that, we amplify each of these fractions by their respective denominators, and we obtain 40x plus 40x over 80 over x times the quantity x plus 2 equals 9x squared plus 18x over x times the quantity x plus 2. Eliminating the denominators, multiplying both sides of the equation by x times the quantity x plus 2, which cannot equal 0. We obtain 40x plus 40x plus 80 equals 9x squared plus 18x. Grouping like terms, 80x plus 80 equals 9x squared plus 18x. This is a quadratic equation, so to write this equation in standard form, we will add negative 80x and negative 80 to both sides of the equation and apply the reflexive property of equations. 9x squared minus 62x minus 80 equals 0. Apply the a, b prime, c discriminant half formula. Identify the coefficients. 1/4 of the discriminant is equal to the difference between the square of half b and the product of the coefficients a and c, which after doing calculations results in 1,681, which is 41 squared. x12 is equal to negative b prime plus or minus the square root of discriminant prime over a, or 31 plus or minus 41 over 9, such that x1 is equal to 72 over 9, which is equal to x, which belongs to our domain open interval 0 infinity. x2 is negative 10 over 9, which does not belong to open interval 0 infinity, so we throw out that solution. How fast was Jasmine skating? Jasmine's speed was x miles per hour, and since x is 8, the answer is that Jasmine was skating 8 miles per hour. This is an example of a motion problem of two entities that travel the same distance. Notice that a sketch was not needed because they both skated the same distance of 20 miles. Example 4. While the rain may be hard to get past, I'll claim that the home of PWBC, South Bank, and Slam City skatees has a romantic appeal specifically for it. London footage always has that telltale signature feel that makes a Nick Jensen sweater vest look spot on. It's also been the cultural epicenter of the European skate scenes. Bianca leaves her house riding a bike at 20 kilometers per hour. Isabelle leaves 6 hours later on a scooter to catch up with traveling at 80 kilometers per hour. Isabelle catches up with Bianca in front of the skating rink. How long did it take Isabelle to get to the skating rink? Construct the dirt tables. Bianca leaves her house riding a bike at 20 kilometers per hour. That's her rate. And Isabelle travels at 80 kilometers per hour. Her rate. Isabelle leaves 6 hours later. So let's let x be the number of hours Bianca travels, such that x is greater than 0. Thus, the number of hours Isabelle travels is x minus 6 hours, x being greater than 6. We know the rate and the time, thus we can use the formula dirt to find the distance. Dirt d equals rt. Distance for Bianca is 20x, and distance for Isabelle is 80 times the quantity x minus 6. Isabelle catches up with Bianca in front of the skating rink, thus they both travel the same distance. This fact leads to the equation 20x equals 80 times the quantity x minus 6, on the domain open interval 6 infinity. Eliminating parentheses and applying the distributive property of multiplication over addition, equivalent to 20x equals 80x minus 480. This is a linear equation with one variable. Separate the variable by adding negative 20x and 480 on both sides of the equation, along with the reflexive property of equations. Add like terms. 60x is equal to 480. Divide both sides of the equation by 60. X equals 8, which belongs to the domain open interval 6 infinity. Substitute x equals 8 into the number of hours Isabelle skated. So Isabelle's time is then x minus 6 hours, which is 8 minus 6 hours, which equals 2 hours. Answer: Isabelle took 2 hours to get to the skating rink. This is an example of a catch-up motion problem. Example 5. The Catalan capital has been the world's Mediterranean skating mecca since the late 90s. Macaba, Parallel, Sant, Forum, Fondo, Barceloneta, Beer Banks, Arc de Triomphe, Mercado, Universitate, and onwards. Barcelona remains a crown jewel on anyone's travel wish for its architecture, weather, and lifestyle. Andy loves skating and takes a train from his apartment in Barcelona to a skating park. At the same time, his brother David takes a train in the same station in an opposite direction. Andy's train is moving at a 15 kilometers per hour slower rate than David's train, and it travels 75 kilometers to the park. After how many hours did Andy arrive to the park if at that instant the two trains were 195 kilometers apart? Construct the dirt tables. Andy's train is moving at a 15 kilometer per hour slower rate than David's. Let David's speed equal x greater than 0. Andy's train, since it's moving 15 kilometers slower than David's train, is x minus 15 with x greater than 15. It travels 75 kilometers to the park, so we fill that in for Andy. At the instant the two trains were 195 kilometers apart, thus the distance traveled by David is equal to the distance between the two trains and the distance traveled by Andy's train. 195 minus 75 is equal to 120 kilometers. We know the distance and rate, thus we can use the dirt formula to find the number of hours they traveled. Dirt, distance equals rate times time. Time equals distance over rate. Time is 120 over x for David and 75 over x minus 15 for Andy. At the same time means the number of hours traveled by both trains are equal. This fact leads to the equation 120 over x equals 75 over x minus 15. On the domain open interval 15 infinity. The GCF of the two numerators is 15. Simplify the equation, divide both sides of the equation by 15, which is equivalent to 8 over x equals 5 over x minus 15. Two equal fractions make a proportion. Apply the cross product property of a proportion. Eliminating parentheses and applying the distributive property of multiplication over addition. 8x minus 120 equals 5x. This is a linear equation with one variable. Separating the variable by adding 120 and negative 5x on both sides of the equation results in 3x equal to 120. Dividing both sides of the equation by 3, obtaining x equals 40, which belongs to the domain open interval 15 infinity. After how many hours did Andy arrive to the park? We found x equals 40. Substitute the value of x in the expression for t, which results in 75 over 25 reduces to 3 hours. Answer: Andy arrives to the park in 3 hours. This is an example of a motion problem with two entities that travel in opposite directions, knowing how far apart they were. Example 6. Vancouver is one of the most ethnically and linguistically diverse cities. The mild climate of the city and the proximity to ocean, mountains, rivers, and lakes make the area a popular destination for outdoor recreation. Vancouver is consistently named as one of the top 5 worldwide cities for livability and quality of life. However, Vancouver also ranks as the most expensive city to live in Canada. Bruno and Katya live 150 miles apart. Once per week, they drive downtown Vancouver to skate. Bruno travels north at 50 miles per hour, and Katya travels west at 60 miles per hour. They both leave at 8 a.m. and arrive to the skating rink at the same time. At what time do they meet? Construct the dirt tables. Draw a line to indicate the distance between Katya and Bruno, 150 miles. Bruno travels north at 50 miles per hour. And Katya travels west at 60 miles per hour. Let t be the number of hours that each of them drove, considering that they leave at the same time. We can use the dirt formula to express the distance as a function of t. Bruno's distance is 50t, and Katya's is 60t. We can use the Pythagorean theorem to write an equation with the variable t. 50t squared plus 60t squared equals 150 squared on the domain open interval 0 infinity. Performing calculations, we obtain 2,500t squared plus 3,600t squared equals 22,500. The GCF of the terms of the equation is 100. Divide both sides of the equation by 100. Obtaining 25t squared plus 36t squared equals 225. Adding like terms, 61t squared equals 225. Dividing both sides of the equation by 61. T squared equals 225 divided by 61. T is greater than 0, therefore t is equal to 15 over the square root of 61, or approximately 1.92. And when we convert that to hours, that's approximately 1 hour and 55 minutes. At what time do they meet? T is the number of hours they both traveled, which is approximately 1 hour and 55 minutes. Thus, Bruno and Katya meet at 9:55 a.m. This is an example of a motion problem with two entities that move on perpendicular directions. The end.